Hi guys, let's take a look at this question. 6.1, they give us a balanced chemical equation of the reaction between sodium carbonate and hydrochloric acid. So nice and balanced here. They ask us to identify the type of reaction above. So this is a gas forming reaction. In a reaction, 10.6 grams of sodium carbonate reacts completely with excess hydrochloric acid. 6.2.1, calculate the molar mass of sodium chloride. So I've done a few videos on how to calculate the molar mass of something. So we're going to look at the three elements here. We're going to look at sodium, carbonate, and oxygen. So there we have sodium, there we have carbon, and there we have oxygen. We're going to look at their masses. So sodium is 23, carbon is 12, and oxygen is 16. So if we look at sodium first, sodium was 23, right? There's 2 atoms, so times 2. Carbon, there's only 1, so it's plus 12. And oxygen, there's 3, so it's 16 times 3. We put that into the calculator and we get 106 grams per mole. 6.2.2, calculate the initial number of moles of sodium carbonate. So we can use this formula because they've given us the mass and we know the molar mass of sodium carbonate. So we can just say number of moles, the mass is 10.6 and the molar mass we've just calculated was 106, and that gives me 0.1 moles. Then they ask us to calculate the mass of carbon dioxide produced during this reaction. So we need the number of moles of carbon dioxide because we can easily find the molar mass to get the mass. So how can we get the number of moles? So let me show you something cool. So we have a balanced reaction here, right? We look at sodium carbonate and we can look at carbon dioxide. What is the mole ratio here? There's an invisible 1, right? There's an invisible 1 there, and there's an invisible 1 there. So the ratio is 1 to 1. So I'm just going to write 2 point here at the top. So the mole ratio between these two is 1 to 1. So if we have just calculated the number of moles of sodium carbonate, which is 0.1, and it's 1 to 1, then that means the number of moles of carbon dioxide is also 0.1. Isn't that so? So therefore you can just conclude that it's 0.1 moles. So now we can easily get the mass, right? Because we know that we can easily get the molecular mass of carbon dioxide, which is going to be carbon. We've just calculated that. We've just seen that is 12 mass, so it's 12. Plus oxygen was 16, and there's only 2 oxygens this time, so 16 times 2. And that gives me 44. So therefore, I can use my formula to calculate that mass there. We have 0.1, we have mass, and we now have molar mass of 44. We multiply 44 times 0.1, and we get 4.1 grams. Then 6.2.4, calculate the mass of sodium chloride produced if 4.87 decimeters cube of carbon dioxide was produced at STP. Okay, so let's go and find in this question the number of moles of CO2 at STP. So we can use this formula because they've given us the volume and we have the molar gas volume at STP as a constant. So the volume was 4.87 and the constant is 22.4. So the number of moles of carbon dioxide at STP is 0.217 moles. So now they want the mass of sodium chloride. So we need the number of moles of sodium chloride, right? So again, we can do our mole ratio calculation here. So if you look at sodium chloride, and you look at carbon dioxide is 1 and sodium is 2. So it's 1:2, right? So that is what we have. This is what we want. So what we have is the carbon dioxide, and what we want is the sodium chloride. So that is 1:2, right? So therefore, if sodium chloride was 0.217, for every one carbon dioxide, there's 2 sodium chloride. So 0.217 times 2 will give me 0,434. So therefore, the number of moles will be in sodium chloride will be 0,434 moles. Okay? So then we can then find the mass of sodium chloride at STP to be 0,434. We want the mass. We can easily find the molar mass. I'm just going to write it on the side. The molar mass of sodium chloride will be 23. So 23, where's chloride? There's chloride. 23 plus 35,5 because it's only one of each. So 23 times 35,5 gives me 58,5. So therefore, the molar mass is 58,5. So I multiply 58,5 by 0,434 to get the mass of sodium chloride at STP to be 25,16 grams. And that is it, guys. See ya.